Hello. Thank you for the kind introduction. I'm Akihiro Umezawa from National Center for Child Health and Development, Tokyo. Today, it's my great honor to talk about our updated progress or study. Human embryonic stem cell-based therapy in Japan. Okay, let me show you the slide so that I believe that you can see a slide here. All right. So actually, I wanna show the slide. So thank you so much. Kamsahamnida. Actually, I wanna talk about the human embryonic stem cell-based therapy in Japan. I'm Akihiro Umezawa from National Center for Child Health and Development, Tokyo, Japan. This is actually a research of National Institute of Health, supported by the Japanese government. In the first slide, I will show you the authorized cartilage product in Japan. Actually, the product is autologous cultured cartilage. We say JAC. This product is provided by the company JTEC, and this product is for patients with traumatic cartilage defect and osteochondritis dissections. So I wanted to generate the cartilage. Not only autologous, but also the allogenic cartilage product. So I wanted to start from cartilage used for raw material for chondrocyte. I used the extra finger because the extra finger has a cartilage and bone, and this is a macroscopic view of the extra finger, and we performed immunohistochemistry with antibody against type 2 collagen, so that the cartilage part can be seen in brown. See, and here and here. So let me show you more about the extra finger. Actually, this is a kind of good raw material because finger has a very nice cartilage. This and here stand in ensemble, here and here. So we have quiescent chondrogenic layer, proliferating chondral layer, and the hypertrophic chondrocyte layer with bone marrow and bone. So I wanted to use this chondrocytic layer as a raw material of the chondrocytes. So I started to cultivate from cartilage. So chondrocytes were cultured from cartilage, and this one is a passage. We say passage 1 and passage 4. They start to proliferate in vitro, and actually I want to mention that the size of the chondrocyte became enlarged at every passage. So I wanted to implant these cells into the immunodeficient mice so that we can obtain the cartilage like this. So this one is hematoxylin histological analysis, and we see a cartilage here and here, which is these cartilage exhibit the metachromagy with taurogen blue staining, and this cartilage can be stained with produce type 2 collagen abundantly. So it's this is kind of goal for cartilage regeneration by using cartilage itself. So in the during actually this one is we at the 20 weeks 21 weeks in addition to the cartilage, they started to have bone and as well as bone marrow here, and these brown cells, brown stem cell, osteoblasts. They started to produce bone. Actually, we started to use chondrocytes as a resource of to generate a cartilage. However, actually, we see bone formation at 21 weeks after the implantation. And so let me show you the actually this is a cartilage, and we see saffron red stained cartilage. In the red part is a cartilage. Cartilage is here. This part of the perfect cartilage. In addition to the historic cartilage, we see bone formation, and we see bone marrow. So from the viewpoint of the cartilage generation, at the longer period of ex vivo implantation causes a bone formation. Even we started with chondrocyte, chondrocytes derived from cartilage that is itself. So we change our mind because we have successfully have human embryonic stem cell. We have so we wanted to generate the cartilage by using human embryonic stem cell as a raw material. This is because we have completed the clinical trial by using hepatocytes. Hepatocytes are hepatocyte derived from human embryonic stem cell. So we finished the clinical trials as well. Likewise, we wanted to generate the cartilage for the future orthopedic diseases. So I wanted to generate the cartilage from human embryonic stem cell. This one, this purple colony is a human embryonic stem cells, and the cartilage could be formed with human embryonic stem cell derived chondrocyte in immunodeficient mice. So we started from a human embryonic stem cell. We generate the embryoid body on the collagen, and then attach these cells on the collagen 1 coated 10 centimeter dish, and then we cultivate them for 60 days, and then we obtained a cell sheet which are stained with Russian blue. We implanted each sheet into the immunodeficient mice, and then we obtained the cartilage here. So in detail, actually, the embryo body is like this. Embryo body formation for 4 days. We did the embryo for 4 days, and then cultured for 6 days for chondrocytic induction, and then generated cartilage sheet was implanted into the immunodeficient mice, and then we have cartilage here. All right. Okay. I want to show you how the cartilage is in macroscopically and microscopically. At the 30 days after the implantation, we see once cartilage with a diameter of more than 5 millimeter, And then at 60 days, we obtained another cartilage here with a diameter of more than 5 millimeter. So we obtained Alcyon blue stained. Oh, here, see, Alcyon blue stained clear cartilage. It was formed after a longer period of implantation. So, however, it's a round, and so actually for the future clinical trial for the children's disease, we wanted to implant these cartilage to the trachea. So we aim to implant the cartilage into the nodular trachea because in children's hospital we have a patient with a defect in the patient's trachea. So we implanted the generated cartilage here and sutured. We sutured the cartilage with trachea here and here and here, right? And then the trachea of the nodular was excised and fitted into the 2 millimeter times 2 millimeter cartilage, and the trachea was removed at 4 weeks later, and we see a very nice cartilage at the implanted site. Okay, in the next slide, I'd like to show you how the histology is. And we see a cartilage here, implanted, so grafted cartilage, you can see there. So the cartilage was implanted into the nodular trachea here. So we see cartilage here, the grafted cartilage were circled by in yellow. So in Alcyon blue stain, we see a cartilage here and here. Let me see. Yeah, here and here and here. So we are very happy for this implantation into the trachea. So we wanted to produce a cartilage sufficient for clinical use for the future clinical trial in the orthopedic surgery field, and especially I want to emphasize that we want to generate stable production of cartilage with 1 centimeter in the diameter. So we want to see the sheet-like cartilage. So successful one is we obtained the elastic hard cartilage with a diameter of 5 to 8 millimeter here. So histology we generate the vertical histology here by hematoxylin eosin stain and Alcyon blue stain here. Clearly, these are elastic, hard cartilage can be generated in the sheet-like structure with the diameter of 5 to 8 millimeter. So we want to generate we successfully generate a sheet in the right. So we wanted to implant these cartilage sheet into the immunodeficient mice subcutaneously with cell sheet was put into the nylon bag and then implanted them into the nude immunodeficient animal. Actually, the 5 cell sheets were implanted in the nylon bag to increase cartilage size, and we wanted to have a sheet-like cartilage. So actually, this is a slide. Actually, it's like a sheet is not so much beautiful. However, we have many cartilage here and here, 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 and here. So we use the 5-sheet implanted one in the nylon bag, and then we implanted this sheet into the animal for 30 days. After that, we resected them. So we see a cartilage with diameter more than 3 centimeter. This one is 5 centimeter. So we are really excited about this result. So in the summary, I want to mention that the cartilage with the area of 2 centimeter times 3 centimeter was formed in vivo. I want to show the last slide. So in the summary, what I want to conclude is that the use of type 2 collagen and the longer color period promoted chondrogenic differentiation. Nude rats survived for 4 weeks after implantation of cartilage-like tissue into the trachea. However, the implanted cartilage is not joined to the recipient tracheal cartilage. There's no fusion jointment between the donor and the recipient cartilage. So, in the future, in the orthopedic surgery, we seek the aspect in which allogenic cartilage derived from human embryonic stem cell, can contribute to clinic. So, all right. Thank you so much. Actually, I'm a kind of very introduce our study from the basic aspect, and also I believe that we focus on the allogenic type of collagen. For that, probably in the future we may need a scaffold for the cartilage formation, and such as PLGA, like lactic glycolic acid, and so it could be elastic to generate the ear, nose, and for the trachea. And of course, I wanted to contribute the orthopedic surgery. For that, we need help from you, from your member of this excellent meeting. I mean, the Korean Society of Stem Cell Regenerative Medicine for Locomotive System. So if you have a request, I would like to contribute to your member through probably I have a friend in Korea, Peter, Professor Kim Seok-jun. Maybe I believe that he may be of help to connect Japanese basic researcher to excellent Korean orthopedic surgery. Thank you so much. I'm happy to accept questions and comments from you guys. Thank you so much. I stop here. Bye. 감사합니다.